Hi, I'm Byjumax and I blog byjumax.blogspot.com. Today's screencast, I'm going to discuss how we can use a .NET and Matlab to develop financial applications. There are a lot of inbuilt financial functions available in Matlab that you can actually easily use in your client application. You can see the typical architecture. Here I'm going to discuss only these two boxes. One modification to this architecture can be you can actually move this analytical lib to the service layer itself. So these are all the requirements. Now today we will call the BND price function from C# application. For that I'm going to write my own function around BND price, and will convert that algorithm to or .m file to .NET assembly. So here's the documentation for BND price. So we will be interested in the second signature, which accepts yield, coupon rate, settlement date, maturity, period basis. So 6 parameters actually we are considering, and the rest of these parameters will be taking a default values of theirs. So you can see here the face value and par value. Default value for that is 100. So in this documentation mentions. Yep. And what is this period? Period is nothing but the coupon per year. We can specify 0 to 12, and the basis is it's a day count basis for the instrument, that is actual by actual and 30 by 360, etc. So I have written a wrapper function which just delegate its call to the BND price function, nothing extra. So this is my BND price, and the file name is my BND price.m. The file name and function name should be same. I'm delegating this my BND function price call to the BND price function, which is a MATLAB financial toolbox function. This is what I'm going to do. You can write your own algorithms using the MATLAB inbuilt mathematical functions. For the simplicity, I'm just taking the inbuilt BND price function itself to price a fixed income instrument. Now first we try out this this command my BND price and check the results. Evaluate selection, go to command window, we got the answer. You can notice that my BND price returns two matrices. First one is price and the other one is accrued interest. So the price is here is clean price. Now yield have passed three different values, and it's a matrix 0.04, 0.05 and 0.06. So corresponding price is generated here, 104.8106, 99.9951 and 95.4384. You can see that's a decreasing order. Why? Because the yield values are increasing here, and the period is here semi-annually, and basis is actual by actual. So I got an output which is a clean price and the accrued interest. Now we will convert this algorithm to the .NET assembly. So MATLAB provides an inbuilt tool for this, so we don't have to worry about how the marshalling will take place and all these things. So it can be done, this can be done very quickly, and we can convert these our algorithms to a .NET assemblies with the help of .NET deploy tool. You can type deploy tool. So what are all these steps for the deployment of a particular algorithm or conversion of one MATLAB objects to a .NET object? So first we need to create a project, then we have to add files or algorithms. Especially two kinds of files are accepted. One is .m files and another one is .max files. So we are not discussing .max files in this screencast. We are only discussing .m files. And the third step is build the project, then package. We'll discuss each step in detail. Now first part is we need to create a project. So I'll just say my fin lib. So I'm selecting here as a MATLAB builder for .NET. Now I need to add files, my BND price. So I had that. I'll just save this project. Now settings, coming to the settings. So .NET. Now you can see Microsoft framework 1.1 or 2.0. So I'll be using 2.0 is my target Microsoft framework. And the assembly type is private or shared. Private is you can use in your application, private, and if you select shared, then it will be installed in the GSC, global assembly cache. And there are a number of other options you can specify. The component name, you can specify a different component name, and generate verbose output, toolboxes path, C++ compiler, additionally include directories, etc. Warnings, packaging. So in packaging you can see that include MATLAB component runtime. So if you are actually using these assemblies in a different machine where MATLAB is not installed, you require certain runtime libraries to run your algorithms. So that is actually provided by this MATLAB component runtime. So if you include that in your package, you can directly execute that in any other machine which doesn't have MATLAB installed. So since we are actually in our client machine, that is this machine itself, MATLAB is installed, then we don't have to tick this option. So okay, now we'll save. So we have changed the settings, and now we build the project. So you can see that the compilation is completed. Let's go and see what are all the files generated before packaging it. You can see two folders, distrib and source. So source, this is our wrapper class for my BND price, and this is our XML file, which is a documentation file, and a number of other files. So as a programmer, mainly you might be interested in distrib folder, which contains two files. One is myfinlib.dll. This is our actual assembly that we are going to refer in our C# client application, and .ctf file. So this is .ctf stands for component technology file, where your actual M file is archived and encrypted using advanced encryption algorithms. Okay, now let's package this particular component. Now the packaging is completed, and now we can see two more functions, two more files added to this directory distri folder, that is underscore install and my finlib underscore package. So it will underscore install is a batch file, and this package underscore package file contains some information about what all the files needs to be installed in the client machine. Okay, so you can share the distri folder with your colleague who is developing the client side components. Now coming back, and this is our client application, which has settlement date, maturity date, yield, and coupon rate, etc. These are all the parameters to our my BND function, and then one grid view which displays the results. So one form, and the project name is financial project. So in order to use our assembly, we need a reference to that assembly. Let's add the reference from the distri folder. From the distri folder, where is that folder? Okay, financial project, my finlib, distri folder, and the assembly. So I have added here my assembly, which has that function my BND price function. We also need MW array assembly, which is nothing but convert the C# data type to a MATLAB understandable format. In MATLAB, all the data type is considered to be a matrix. For example, if we enter a symbol string, it is considered to be a one-dimensional array of characters, or array of characters. So we need similar thing in our project. So if the MCR is installed, MATLAB component runtime is installed, or MATLAB is installed, so you can go to this program files, MATLAB, and toolbox, .NET Builder, bin Win32, .NET Framework. So you can see that this assembly, we need to refer this particular assembly. Now coming back to our my bond price function, this is our code behind for this design. So I have referred these two libraries arrays. You can see that have written main logic here in BT and BND price click. So get yield function, get yields is called, which is nothing but returns a double array. Yep, it returns a double array. And coupon, it's again a numeric MW numeric array. This is a typical MATLAB data type, and you can see it's a character array. So let's go back to our workspace. You can see here yield is a double array, and settlement date is a character array, and maturity is also character array, and rest of the things is like a double array. So this is what exactly I have done here. So MATLAB numeric array, which is a double value array, and this is a character array. Now I have created a object of my FinLab class. You can see that. So if I have mentioned only my my FinLib, so by default the class generated against this will be my FinLib class. You can also option to change that. Just let me write. So have converted everything into a MATLAB understandable array. Let's go and see what is this MW array. So MW array is the superclass, and you can see that different type of arrays is derived from this MW array. For example, MW numeric array, MW logical array, MW character array, MW structure array, and MW cell array. So the superclass is our MW array, and all these are types defined in the MWArray.dll. And this when we install MATLAB command runtime MCR, then automatically this particular assembly will be installed in the client machine. Now coming back to our .NET client, so I'm just calling the my BND function, and the first parameter is the number of output. So we have two matrices. The output is two matrices, one is price and the other one is accrued interest. And I also have mentioned all the other parameters: yield, coupon, settlement, maturity, period, basis. And I am just displaying that whatever I am getting the result in a grid. So you can see it's a logic here. I will copy paste this the entire code in my blog itself, so you can refer later. So let's run this program. There's a mismatch in the using statement. It's not finance lib, is my FinLib. Okay, let's run this again. Up, the window comes up. So we'll first try the same using the same values which I have tried earlier in the MATLAB command window itself, and compare the result. So I'll just click the price function. Here is our results. So we'll compare this with the earlier answer. You can see 104. So we get the same result. Now we'll try out with different values. For 5, for 6, yield values for 7, for 8 for 9.05, and the coupon rate is 0.45. You can see we get the answer really fast, and it's very easy to use, and you just mocked a $1 million function within no time using MATLAB deployment tool. I hope you enjoy this video. We'll come back with more videos on this and discuss the various architecture you can use in developing a complex financial applications. Do write your feedback in my blog. Thank you.